So now let's say resolution of more than two vectors. Before I will do the resolution, I have to explain the concepts so you can know how to resolve any number of vectors. I will use table first before we will be solving without table. So let's say we have a vector like this. Let's call this f1, f2, f3, f4. Now let me add more. f5, f6, f7, f8. So I want to use enough force so that we can see it clearly. Call this place theta 1, theta 2, theta 3, theta 4, theta 5, theta 6, theta 7, theta 8. Now we want to resolve all these forces into horizontal and vertical. So there are sign conventions you have to know. If I have cardinal points this way, anything you write here will be plus. If this is graph, if this is origin, if you label your graph, everything you write here is plus. Any number you write here is minus, and any number you write here is minus. So we are using this sign convention here. So that means this place will be plus, plus, minus, minus. So the next thing is that all the forces here must have angle. But take note, there are some forces here that have special angles. So now any force that falls on this horizontal line, this is horizontal line, the angle is 0 degree. And any force that falls on this vertical line, the angle is 90 degree. Please take note. So this f5 is the one that can have either theta 1 or theta 2. So take note of this point. Any force on this horizontal line, the angle is 0 degree. Any force on this vertical line, the angle is 90 degree. Take notes. So now if I ask you in this diagram, how many angles do you have here? You have 8 angles. That is theta 1, theta 2, theta 3, theta 4, or to theta 8. Now out of these angles, which ones are to the horizontal? If we say to horizontal, so if I have a line here, any angle I have here is to the horizontal, you see. So this angle is to the horizontal. Now any angle you will have here is to the vertical. So now we can use any angle, either the one to the horizontal or vertical. Remember, we have explained that anywhere the angle touches cos, the other one is sine. So but in order not to cause confusion, you can decide to be using angle to the horizontal. What are the angles to the horizontal in this diagram? Trace it. They are theta 1, theta 4, theta 5, and theta 8. You will notice all these ones, they are to the horizontal because this is horizontal. So we have angle here, angle here, angle here, angle here. So they are to the horizontal. Anyone you have here is to the vertical. You can see is to vertical. So now the angle I want to consider are the angles to the horizontal. so that all my horizontal components will be cos. But anyone can be your angle, either vertical or horizontal. But if you have choose your horizontal angle here, then horizontal is cos, vertical is sine. If it is theta 2 I want to use here, then this vertical will be cos, then horizontal will be sine. So that we can have uniform, so I will just pick all the horizontal angle. So now let's form this. All the forces will have angle. So to solve a problem on resolution, so you have to list all the forces first. We write force angle, horizontal components, that is x, vertical components, that is y. So now what are the angles you have here? So I have theta 1. Forces you have here, I have F1, F2, F3, F4, F5, F6, F7, F7, F8. So now what I'm doing here is that I list out all these forces, F1 up to F8. So the concept I'm using here is still the same procedure you are going to use if you are solving the real problem. Now we will use number in our next video, but now you have to understand all these concepts I'm explaining. So now the next thing we have is angle. What is the angle for F1? Now where does F1 lies? You will notice that this F1 and F3 lies on the horizontal, and any force that lies on horizontal will have special angle, and that is 0 degree. So that means F1 we have 0 degree, F5 we have theta 1. The angle to the horizontal is the one I'm picking, take note. So but now we are doing it accordingly. Now F1 we have 0. See where F2 lies. F2 is on this vertical, and any angle here we have special angle, that is 90 degree. So F2 we have 90. F3 is also on this horizontal line, it will have 0. F4 is still on this vertical line, it will have 90. Now the remaining one, apart from this cardinal points, the remaining one will now have these horizontal angles. So now F5 we have theta 1, the horizontal angle. So but anyone that falls on this horizontal or vertical we have special angle, and that is what you see there. So F5 we have theta 1, F6 we have theta 4, angle to the horizontal, take note. F6 we have theta 4, F7 we have theta 5, angle to the horizontal. F8 we have theta 8, angle to the horizontal. Now do you notice I'm not picking theta 2, theta 3? If I pick it there is no problem, but picking all the horizontal angles, it shows that all my horizontal will be cos and my vertical will be sine. So F7 we have theta 5, F8 we have theta 8, like that. So now all my horizontal will be cos now, and vertical will be sine. That is why I'm choosing angle to the horizontal, so that everything will be uniform. So but remember, you can pick anyone. But for your case now, you can be picking all the angles to the horizontal. So all your horizontal will be cos, vertical will be sine. Now we have known all the forces, we have also known all the angles. Now the only thing we need now is it going to be plus or minus to horizontal or vertical? Now F1, start from F1, the force F1. Do you notice now that F1 is already on the horizontal? So now that horizontal, the sign there is plus, as in horizontal. F1 is already on horizontal. So that means that will be plus F1 cos 0. Why? To the vertical, this F1, move it like this to the vertical. Now we are going anti-clockwise. You know, clockwise means the way your wall clock move. Then anti is backwards, opposite to the way your wall clock move. Then in this case, we are moving anti-clockwise throughout. So now F1 is on horizontal and is plus F1 cos 0. Now that is horizontal. The same F1, move it to the vertical. So it's moving this way. So to vertical is also plus. So that means to the vertical, this is also plus F1, but to be sine 0. We have the forces and angle already. Now move to F2. So this is F2. It's already on vertical. So the sign there is plus. So that will be plus F2 cos 90. So this same F2, we are moving anti-clockwise. Remember, it's vertical already. Then move it again to the horizontal. Each force must have both vertical and horizontal, but it's the sign we need. This is in vertical already. Now move it to the horizontal. Remember, we are doing anti-clockwise. So to the horizontal, the sign is minus. So this will be minus F2 sine 90. So one will be cos, one will be sine. Now F3, this is F3 already on this line, horizontal. So on horizontal is minus. So F3 cos 0. Then this horizontal, move it again. We are moving anti-clockwise, as in like this. So we are moving anti-clockwise. Take note. So now this will be minus again, minus F3 sine 0. Now F4, F4 is in vertical already, so that is minus, and to the horizontal will be plus. Remember, anti-clockwise, that is this way, anti-clockwise. So that will be minus F4 cos, no, it's in vertical already, so vertical is minus F4 sine 90 and plus F4 cos 90, because if you move this vertical to this side, that is to horizontal. The next force is F5. F5, this is our F5. So move the F5 to the horizontal, it will be this way, as into horizontal, that is plus. Move the same F5 to the vertical, that is also plus. So we have plus F5 cos theta 1, and again plus F5 sine theta 1. So let me do one more. So F6, this is F6. Move it to the horizontal, that the sign is minus. Also move it to the vertical, the sign is plus. So that means to horizontal is minus F6 cos theta 4 plus F6 sine theta 4. So follow the same trend and do the rest. After that, we add everything here and everything here, then we are done. So let's see number. Let's use number now to solve something like this. So see the next video.